All right, so today we're going to look at lenses instead of mirrors. There are two types of lenses. This is a convex lens, and this is a concave lens. Before we look at the two different types, though, we need to pick up some vocabulary. So the vocabulary for lenses is a little bit different than the vocabulary for mirrors. First off, we're going to have this O, which is the center of the lens, and it is referred to, as the optical center. So this is O, it's not a zero, it's an O, and it's the optical center. We now have two focal points. We have F, which is the real focal point, and we have F prime, which is the one down here on the left. F prime is the virtual focal point. This is because for a lens, unlike mirrors, for a lens, the left-hand side is virtual and the right-hand side is real. The last thing we have is the same as mirrors, and that's the principal axis. All right, now that we've gotten the vocabulary out of the way, we can come down here and look at the rules. They're somewhat similar to the rules for drawing mirrors, which helps make things easier. First of all, we draw a ray parallel to the principal axis, which should be pretty familiar. When you're talking about lenses, your rays get refracted, not reflected. So here we draw a ray parallel to the axis, and then it gets refracted through the real focal point. Then you draw an incident ray through the virtual focal point, which is refracted parallel. Okay, well that says that it's refracted through the center of curvature, which is not accurate. It is refracted through the optical... No, it's not right at all. Alright, so this should be that it's refracted back parallel to the principal axis. So, yeah. Now the third one is the most different from mirrors, and it's also the easiest. For lenses, your third ray is drawn through the optical center, so through O, and it just keeps moving in a straight line. It is not refracted at all. Straight through O. Alright, well let's practice one, and I promise that I will do Rule 2 correctly, even though it is written incorrectly. Alright, so you start out with the incident ray that's parallel, as we always do. This goes to the center of the lens, not the edge of the lens. We draw as if it's refracted right in the center. It's not actually how it works, but it simplifies things significantly for us. Alright, that light ray, that first light ray that's parallel, is refracted through the real focal point. Then the second incident ray goes through the virtual focal point to the center of the lens and is refracted parallel. Our third and final ray goes straight through the center of the lens, through the O, and just keeps going straight. See, it's literally all one line, super easy. You can see our image has formed over here. And images share the same characteristics when made by lenses that they do when made by mirrors. So this image is real, it's inverted, and it's enlarged. It's on the real side of the lens, and it is inverted because the intersection is below the axis, and it's enlarged because this image here is bigger than this here. And so that is how you draw convex lenses, which happen to be converging lenses. You can tell this because they take these light rays here that are spread out and they focus them into one point. That's what a converging lens does. Alright, so now we are going to look at concave lenses. Now, the rules are not significantly different than convex lenses, but they are a little bit different. This is unlike mirrors where the rules for concave and convex mirrors were exactly the same. So let's get started. Concave lenses are diverging lenses. So this means all of our light rays are going to refract away. The lens is going to spread them out. So the rules for concave lenses, you draw your incident ray parallel to the principal axis, and it is refracted through the virtual focal point, F prime. You then do an incident ray that goes through the real focal point, which is F. This is refracted back parallel to the principal axis. Your third ray, the same way it was for convex lenses. It goes through the optical center O, and it is not refracted at all. It just continues moving in a straight line from O. Now, you may notice the only difference here is that you go through the virtual focal point first and the real focal point second, unlike back up here for convex lenses where you went through the real first and then the virtual. All right, so let's do an example of this. So we're going to have our incident ray that's parallel. Now, here are a variety of things people are going to try to do. They're going to try to go through the real focal point. If you draw this, it should not look right to you because this is a diverging lens. This sends rays outward. Sorry about that. So this should not look right. This is not what a diverging lens would do. Okay, so we have to use the virtual focal point, right? That's over here. This is not right either. Look at it. This isn't a mirror. It's not a solid object. Why would the light come back this way? It wouldn't. So here's what you do. You line up with that line that's right there now, and you go the other way. Look, the lens is diverging the light outward. Next, we have an incident ray that's lined up with the real focal point, but you only draw it as far as the lens. That line gets refracted parallel to the principal axis. And then finally, you do your ray through the optical center that goes through the optical center and just keeps on trucking. So these do not intersect on the real side of the lens, but your brain is like, I know these three rays of light came from the same place. I am sure of it. And if they traveled in a straight line, which I'm a brain, I don't know any better, they probably traveled in a straight line. And if they did, they must have come from back here. So that's where I'm going to tell you that the image is. So in this case, your image forms here, and we can characterize this image by saying that it is virtual because it's on the virtual side of the lens. It's upright because the intersection was above the principal axis, and it's reduced because the image is significantly smaller in size than the object. Look at this answer. This is the same answer that you got for convex mirrors, which were also diverging. This is, again, the only type of image that this concave lens can create. So both of the types of diverging optical instruments, whether it was the concave lens here or the convex mirror from before, both types of diverging optical instruments can only make one type of image, and it's virtual, upright, and reduced.